Recently in my weekly live stream, I went over an implicit differentiation example that I think you'll find kind of helpful. So I wanted to show you the portion of that live stream where I did this problem. So what we're going to be doing is finding dy dx if x minus y all over x equals 16y. And this is a great example because it's going to show you the exact steps that you can apply to pretty much any implicit differentiation problem and should help make your life a lot easier. So without further ado, let's go ahead and jump on into the example. So again, just like we did in the last example, first thing you want to think about, what is your function? What is your variable? Well, since we have a y on top here, y is going to be our function. And we have an x on the bottom, x is our variable, right? That's all there is to it. Whatever is on bottom is your variable, whatever's on top is your function. So basically what we know right away, right, based on what the problem is telling us to find, we're going to need to find the derivative with respect to x, because x is our variable, because x is on bottom here. So we're going to take the derivative with respect to x of both sides of our equation. You know, actually there probably is two different ways to do this problem specifically. We can just go right off the bat, take the derivative with respect to x, and you know, we'd probably have to use quotient rule over here. One other option we have is, instead of taking the derivative right away, we can rearrange this equation a little bit, and that might actually get it into a format that's going to be a little bit easier for us. And what I mean by that is, if we think about how to get rid of this fraction, because quotient rule can be kind of messy, we would basically just multiply both sides of our equation by x. And that would cancel the x down here and move it over to the right side. So we would get x minus y equals 16y times x. So I think honestly, this is probably going to be easier to take the derivative of with respect to x. So that's what I'm going to do in this case. If you want some practice with quotient rule, definitely, you know, do it the first way. Quotient rule is another one of the formulas on my free Calculus 1 study guide. So if you need that, go grab it. Link is down below in the description. But we'll go ahead and take the derivative with respect to x of this equation. So we're not going to do that one. Instead, we rearranged it into this this equation that'll be a little bit easier to take the derivative of. So basically, we just want to kind of think about each of these terms as we go in here. So the derivative with respect to x of x is going to behave the way that you would expect it to, right? The derivative of that is just 1. And that's because x is our variable. However, the derivative of y with respect to x is going to be a little bit different, because y is an unknown function of x. So we really have to treat this as the derivative of y with respect to x, the derivative of some unknown function with respect to that function's variable. Since you don't know the function, you can't possibly know its derivative. So the best we can do here is to say the derivative with respect to x of some unknown function y is just going to be dy dx. And that's going to be consistent as we go through these implicit differentiation problems. Then to take the derivative of the right side of our equation here, we are going to have to do product rule, which is also one of the formulas on my study guide. But we'll go ahead and say that 16y is one of our functions and x is our other function. So we'll say f is 16y and g is x. The derivative of 16y, again, we don't know the derivative of y, but what we're basically going to be able to do is just say this is going to be 16 times dy dx. Because the derivative of a constant times a function is just going to be that same constant times the derivative of the function. And the derivative of y, like we set up here, is dy dx. Then the derivative of x, again, that's going to behave exactly the way you would expect it to. Derivative of x is just 1. So now product rule says that we would just basically multiply across here. So we're going to get f times g prime, so 16y times 1, which is just 16y. And then 16 dy dx times x, and then we'll add those together by the product rule. Product rule says you multiply across and add them together. So 16 x times dy dx. And now what we want to do, now that we've taken the derivative of both sides of our equation, we just want to add or subtract all of our dy dx terms to one side of the equation, add or subtract all the non-dy dx terms to the other side. So we're going to subtract 16x dy dx from both sides to move it from the right over to the left. And then we want to subtract the 1 from over here to move it over to the right. So that'll cancel there, and we will be left with negative dy dx minus 16x dy dx. And then on the right side, we're going to have 16y still, and then minus 1. So now that we've gotten all of our dy dx terms onto one side of the equation, all of our non-dy dx terms to the other side, we will factor out a dy dx from the left side of our equation. Factoring out a dy dx from a negative dy dx is just going to leave us with negative 1. We do need to have this negative 1 here to kind of hold the place of this term that was here. And then factoring out the dy dx from this term is going to leave us with minus 16x. And then on the right side, we did not do anything, so that's not going to change. And at this point, we have only a single dy dx term. So to get it all by itself, we just have to divide whatever's in the parentheses here over to the other side. So we will get dy dx equals what was already on the right side of our equation divided by what was within the parentheses here. And that's going to be it. I mean, we could simplify this a bit if we multiply the top and the bottom by negative 1, just so that there's less negative signs. Negative 1 divided by negative 1 is just 1. So it's not going to change the value to multiply the top and the bottom by negative 1. So doing that is just going to give us dy dx equals 1 minus 16y over 1 plus 16x. So that's really it. There isn't going to be any more simplifying we could do there, and that solves for dy dx. Well, I hope you found this video helpful. Like I said, this was one of the topics covered in one of my recent live streams, which I'm doing every Monday night at 5 Pacific, 8 Eastern. So be sure to hit that subscribe button down below, hit the bell icon as well, and turn on all notifications so you're notified when I'm going live next Monday, and I hope to see you there. Thanks, and see you next time.